So these dots might look familiar to you as an example of a geometric sequence. And we were talking about what would happen in the next drawing. So if I were to draw the next drawing, let's get my pen going here. I would have, oops, I would have 5, 1, 2, 3, 4, 5 along the bottom, and then 4 on top, 3, 2, 1. So that would be my fifth drawing. And it would have, I don't know why my marker is so small today. And it would have a total of 10, no, not 10, sorry, 15 dots in it. Okay. So we have 15 dots. If I go out to my sixth drawing, I would have 1, 2, 3, 4, 5, 6 along the bottom. 5, 4, 3, 2, 1. That would be my sixth, and it would have 21 dots. Okay, so that tells us my individual dots. Now, if I want to know the total, that would be the sum of the sequence. So sum, oops, refers to addition of the terms. And so my sum of the series, I'm going to have the 1 from the first one, the 3 from the second, the 6th from the next, the 10th, then the 15, and the 21. Those are all the dots from our drawing, okay, up to for the sum of the 6th term, okay? So when I add them all together, I get 56 dots. So what that tells me is that there are 56 dots drawn out right now. Okay, for every pyramid that I draw, I'm adding those dots. Okay, now the dots don't really have a meaning to it, but if I go down to my example with our infection, that's where things get really kind of useful. Okay, if I have a person that gets sick, and then they get 2 people sick, and then they get 2 more people sick, and then they get 2 more people sick, realistically, I don't really care that much about how many people are getting sick at a time. I care more about how many total people are getting sick. So I have 1 row, 2 rows, 3 rows, 4 rows. If I kept this going and doubled it, at the 5th row I would have, so I have 1, 2, 3, 4, 5, 6, 7, 8 right now. We're going to double it, so that's going to get me 16. We're going to double it again. Let's write out what we have so far. We have 1 person, 2 people, 4 people, 6 or 8 people, 16 people. At the 6th row, we would have 32 people because I'm multiplying by 2 every time. And then I would have, let's see. And then the 7th row, I would have 64 people. So by the 8th row, 128 people would be getting sick. Now that's a lot of people, but what really matters to me right now is how many total people are sick. And so what I'm going to do is I'm going to add up those terms. And when I add them all up, I find out that I get 255 total people sick. That's a lot of people that get sick, okay? So what I'm looking at is my total, and I added up all those people that are getting sick each time. Now, there's an easier way, rather than just writing out the addition, to finding out how many total people. And so here's what we're going to do. We have an equation for the sum of a series. Oops. And it says S sub n is equal to a sub 1 times r to the n minus 1. Notice how my minus 1 is not being subtracted from the n. The n is the only thing in the exponent, over r minus 1. My values are all going to mean the same thing. Okay, n is the spot. R is the rate. S sub n as a whole is the sum at that spot. And R sub 1 is the first term. Everything means the same thing it did. Okay, we just have our variables in a different spot. Okay, so let's do an example using this equation here. Okay, the first thing I do when I do my example, anytime I'm writing out in a problem, is I'm going to write out that equation again. So I have S sub n, let's make that look more like an S, is equal to, ooh, my eraser's doing all kinds of funky things today. Or my marker. Let's get that eraser. Here we go. Is equal to A sub 1 times R to the n power minus 1 over R minus 1. Okay, so if I have the sequence, let's say I have a sequence that goes 2, 6, 18, 54, dot, 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 and it keeps going forever. My first thing I'm going to do is I'm going to find that common ratio. I'm going to find what am I doing when I go from term to term. So I take term 2 and I divide it by term 1. So I have 6 over 2, which is equal to 3. So my R value is equal to 3. The next thing I'm going to do is I'm going to identify my A sub 1, or my first term. My first term in my list is 2, because that's the first thing that shows up on my line. So I'm going to use those values and plug them in to find my explicit equation. So the only things I'm plugging in, I'm leaving the n as it is. So I have S sub n is equal to, my A sub 1 is 2 times 3 to the n minus 1 over 3 minus 1. Now I'm going to use that equation to solve. So if I want to find for the 6th term, let's say, the sum at the 6th term, then that means that n equals 6, so I'm going to replace all my n's with 6. So S sub 6 is equal to 2 times 3 to the 6th power minus 1 over 3 minus 1. And then I simplify. So I'm going to start with my parentheses. Well, inside my parentheses, I have an exponent. 3 to the 6th power is 729 minus 1 over 3 minus 1. So as I continue to solve this, I have 2 times, I'm going to do that parentheses, and I get 728 over, and I'm going to do this subtraction here too. 3 minus 1 is 2. When I plug this into my calculator, I get 728. I multiply by 2 and then I divide by 2. So that is the total after 6 terms, or after 6 times for my explicit equation. So that means that my S sub 6, or my sum at the 6th term, is 728.